Yeah, everyone, welcome to our Python series again. So far we have discussed about Python functions, and you can see in my screen. So this is what we were discussing, right? So if you see in my agenda section, there's something called decorators, which was left from my end. Then this type hint annotations and all we can discuss, but these are very normal things. But these decorators are, I mean, is one of the important topic that we should know about. Okay, and in our AI course we will be going to discuss about that today. And so what I do today, I'm dedicatedly spending some time to teach you decorators. Why? Because it's a very important topic to learn, as well as later on when we work on Flask or Fast API, which all are web framework built on Python. So we will need to use decorators there. Okay, so decorators are widely used in these projects, and that is why we need to work on that. Okay, so this is the day 11 video that I recorded. If you haven't watched that, you can go to the CI course recording and you can watch all the videos. So far I have uploaded 14 videos, and these all videos are in descending order. So the first video is the latest video that I have here. So I really suggest, if you are watching my playlist, so please make sure that you go to the end of that video, start from there, then go up. Okay, I am not changing it now because I just don't want to break the flow. So like people are following my videos, what I can see. So if I somehow change the structure now, then that would be an issue for others who all are watching, right? So I'm not changing the sequence, but all videos are in sequence in descending manner. You can start from here to know the syllabus, then day 1 day through day 3 karke till this day 11 that we have. But if you see, for day 11 we have two videos. Why? Because so today is also day 11, by the way. So when you see the title of the video, it will be day 11 only, because I was supposed to complete this topic in one day. Since I'm not completing in one day, because you can see these topics are taking almost 1 hour video size, and I just don't want to make it too big, because you are learning about this, right? So I don't want to make it too big so that you cannot complete. And that is why what I am doing, I'm mostly um, trying to split it in multiple parts. Okay, so today we will discuss about decorators, and in decorator also we will discuss a lot many things. So today's video may cross more than hour. Okay, so yeah, so what I do, I'll quickly create a new cell and I'll continue here. So I'll use the same notebook where I taught you the functions. Here only I'll continue with my stuff. Okay, so what I do, I just quickly create multiple code cells so that I can understand that things are fine or not. Okay. Okay, so we will discuss about Docker. Now further what I do, I'll simply create a text section and I quickly start what is a decorator. Okay, what is a decorator? So what is a decorator? If I really explain what is a decorator. Now to explain you the decorator, write it here so that you actually get it. So a decorator, yeah, is a function that takes another function as input. Okay, so a decorator is a function that takes another function as input, then extends or modifies its behavior. Okay, so decorator is a function that takes another function as input, extend or modifies its behavior, returns a new modified function without changing the original code. Okay, so you can see the definition. So decorator is a function that takes another function as input, extends or modifies its behavior, returns a new modified function without changing the original code. Okay, so I just rewrite it again. So you can think of it as a you can think of it as a wrapper. Okay, a wrapper for your functions. Like its name is decorator, right? Decorator means what? Decorate something, right? So you can think like decorate is something kind of a wrapper which we apply on top of some other functions that we define using def or using lambda, whatever that we have learned so far. So when we want to apply some wrapper, and what are these wrappers? Wrappers are nothing but this is some other functions which does some modification in my code, okay, in my functions. Okay, so that is the decorator. Again, I'll give you some example to make you explain about it, but I just give you the idea. Okay, first of all, um, if I really tell you, though, if I define a function, let's say my function, okay, my function, and this function is doing nothing. Pass means what? Doing nothing. Okay, this is your normal function. And since I have told that decorator is also a function, so I'm defining one new function called, let's say, my decorator. Okay, my decorator, and is it's also sorry, it also does nothing. If you see, so it is also doing nothing. So this is my function. This is also my function, but the difference is this function is just a normal function, and this function is nothing but the decorator for me. Okay, it's a decorator for me. Okay, so now how decorator works? So as you can see the definition here, a decorator is a function that takes another function as input, extend or modifies its behavior. So I'm calling, let's say, my decorator. Um, I think I need to give some input for this function. Yeah, I have to give some input, or else it will not work, right? So I'm calling decorator. Then I'm passing this function. I'm passing this function. Okay. So this decorator is taking another function as an input, and whatever I do inside this function, that will be called at first. Correct. That's how you should work. So that is the whole and soul, I would say, philosophy of decorator. Decorator is nothing but it's another function which takes another function as input, external modifies its behavior. Okay, so decorator in general we use decorator using @ syntax. So how we write it? We write it like this. This is the function, and I want to apply decorator on top of this function. So I have to give my decorator. Decorator. Yeah. See. So this code is also working. Why? Because this my decorator is just defined as a function. I can call this function like this using this @ syntax. Okay, so this is the very basic idea about the decorator. So this code and this code are the same code, by the way. This code and this code is the same code. Just uh, generally we do not write code in this way. We prefer to use this @ okay. So again, if you do not understand much yet, don't have to worry, I will deep dive more about it, but just I wanted to give you a heads up about decorator. Okay, so let me start with my stuff. Okay, some more proper examples. So we first understand functions as first class object. The first thing that we need to understand. So I'll explain it to you in such a way that you can understand. I'll start with functions since you guys have completed the function video, so you guys are quite um, aware about functions, right? So I will use functions to give you the idea first, then slowly we will grow more knowledge about decorators. So the first thing is functions as first class object. What does this line mean? First class object. So if I create a text file here and let me write, because it would be more good for you guys, right? So if I write that before decorator click, right, you need to deeply understand that Python functions are objects. So you need to read this line. You need to deeply understand that Python functions are object. What does that mean? They are objects. So it means they can be assigned to variables. Okay, they can be assigned to variables. We have done that multiple times. Then passed as arguments, right? Then returned from returned from other functions, right? Stored in data structures, right? So so function Python functions are objects. They can be assigned to variables, passed as arguments, returned from other functions, stored in data structure. So what I do, I'll show you some examples about this each of everything so that you get it better. So the first example that I discuss, that functions are objects, like assign them to variables. Okay, assign them to variables. So this is what I'm going to discuss, this thing, assign to variables. So how does it work? Again, we have done that multiple times in our previous videos, but I'm discussing about it again. Okay, so let me write that function for you. So def greet, this is the function that I'm writing. It takes this one as input, name, it takes name as input, and it simply returns um, let's say f string hello name. Okay, so this is the function defining greet. It takes the name as input, and I'm returning simple hello name. Simple function. You guys now have completed advanced function concept, so you should be good in this function knowledge. So yeah, so now you know how to call it, right? I just simply call greet Tanmay. If I pass my name and execute the code, say I'm getting hello Tanmay. Code is perfectly fine, it's working perfectly fine, no problem in that, right? So now let's say I want to prove that I can assign them to variables. This is one of the characteristic of functions, since Python functions are objects. So so what I'm doing, I can create a value called say hello. Say hello is one of the variable that I'm creating, say hello, then I'm passing greet. So what we are doing here, no parenthesis. I'm not calling this function. If you see here, I'm not calling this function because no parenthesis, right? I'm not calling this function. We are referencing, not calling, right? We are referencing, not calling. Then I can simply print that or maybe like say hello. I can call say hello here, then I can simply pass my name. Okay, and if I also check the type of this greet, you can see that. And then if I simply print the uh, dot underscore name underscore, if I do this, yeah, I'm getting something like this, hello Tanmay. Like here what I did, I simply assigned my function in a variable called say hello. Then I've simply called this say hello instead of this greet. Since this say hello function is referencing greet function, so I can call it like this. And then you can check the type of the function. You can check the type of the greet.name. So by showing this, I wanted to prove that you can assign them to variables. So I assigned my function to the variable, and then I am able to call it, right? This is the one of the first part that I proved, that assign to variables is possible. So this is one of the characteristic of objects, and Python functions are objects. I'm kind of proving that. Okay. Next part is passed as arguments. So I'll show that also as a proof. So 2.2 example I'll show you. Functions can be passed as arguments. Okay, functions can be passed as argument. I will show that. So a different function called, let's say, shout. It takes as text and input, and then it simply return text dot upper, then plus simple. So what is the text dot upper? So if I really show you again, I have not taught strings yet inside Python. So after function, that means after today's video, tomorrow I will upload the strings video. Okay, so in the strings we will discuss about Python string, different methods, different operators available inside Python string. We will discuss about that. Okay, so for now I'll explain this upper thing. Let's see our data, your name, let's say Tanmay. Okay, so inside Python you can apply some methods, like for list you have implemented append and all, right. Same we can do for functions. So what we can do, name, since name is a string, dot upper. So if I do upper, it will simply convert this name to uppercase. If you do lower, you simply convert to lowercase. So in this function also the same thing is happening. Defines out text as an input, then I'm returning text dot upper. So it is converting into uppercase text, and then I'm doing concatenation. So if I want, I can do like this. See, I'm getting this exclamation marks with that, so that's what I'm doing here. Okay, so this is one of the function. Now I'm defining the next function, that is whisper function. Sorry, whisper, yeah. So I'm doing simply lower. Okay, sorry, whisper, yes. Okay, then what I'm doing another function called define apply effect. Function name is apply effect. Okay, it takes the function and some message as an input. It takes two inputs, one function, one Python function, and another one is a message. Simply takes it. Okay, then what I'm doing, I'm simply returning by calling that function and sending that message as an input for this. So this apply effect function will take one function as an argument, matlab something like this will take as an argument as well as the message. Okay, so now what I'm doing is simply calling this function inside this apply effect function, and I'm passing this message also inside the function as a parameter. Okay, that's what I'm doing here. And then if I simply go and if I simply print apply effect, then if I pass, let's say, shout. Okay, if I pass shout, then if I pass Tanmay, if you see, if I call this function, can I say I'm getting my text converted into uppercase? Why? Because shout function I have provided inside this and message went as Tanmay. So this apply effect function is calling this func. And what is this func in our case? Shout is the function. And what this shout is doing? Shout is simply converting into uppercase and showing it like this. That's what I'm trying to show here. Same I will show you for the rest thing, like for whisper. Okay, I simply straight for whisper. If I execute the code, you will see it. So I got Tanmay, then I got Tanmay. So this thing converted as uppercase and this thing converted as lowercase. So this thing is proving that functions can be passed as an argument. That you can see here. In this case, I have passed the function as argument, right? So that is why I wanted to prove this functions can be passed as argument. So I have proven this part also. So far I have discussed about this functions can be passed as arguments, and so we have proven these two parts, assigned to variables, passed as arguments. So these two parts I have proven already. Okay, so now the next part is returned from other functions. So I will prove that part also. So again, this all things I am proving you because I wanted to prove that Python functions are objects. So these are the characteristics which define something as object, and Python functions are object that I am kind of proving to you. Okay, so we'll discuss about that now. So if I create a new thing, let's check the types. Yeah, okay. So I'll use just 2.3. Okay, and then I'll simply create functions can be functions can be returned from other functions. Okay, so we call it as closest to. Okay, so functions can be returned from other functions, so we call it closer also. Okay, so great. So I'll just show you some examples. So let me write one function. Let's say maybe let's say make multiplier. This is the function that I'm writing, make multiplier. Okay, so it takes one input, that is the factor. Okay, and what this function does, so see, so far we have written this kind of functions, right? Define a greet, doing this greeting, then define shout, define whisper, right? So these functions are kind of self-explanatory, right? Like just by seeing the function, and it has a one line of code, so you have a Python knowledge, you can easily understand what this code is saying. But what about this kind of functions where codes are bigger? Like I will write the code, but that will be a bit bigger one, maybe 4 lines of code. But how do you understand what this function does without seeing the logic for now? Because what can happen when you work for company, they will have multiple functions written already for you, right? And that would be like 50-60 lines of function code. So you're not going to read 50-60 lines of code to understand that, okay, what this function is doing, right? So what we do generally whenever we write some Python function in production, so we try to always maintain one doc string. What is doc string? Doc string is nothing but like a simple string that we write, that I just show you, the string that we write, so that it's kind of a description about that function, what it does, so that tomorrow if any new guy is joining my company, they don't have to go through the code and understand it. There's a simply just they can go to the code, they read the docs, they'll get to know the intent of it. Okay, so I'll just write the doc string of this function. Okay, so it returns a new function. Okay, it returns a new function that multiplies by factor. Okay, so this is the doc string that I have defined. So this is the meaning of this function. It function returns a new function that multiplies by factor. Okay, great. Now my example was supposed to be closer example, right? That means functions can be returned from other functions. Okay, so what I'm doing, I'm writing another function inside this function that is called as nested functions. So again, I have discussed about that in previous videos. Okay, nested function. So let's say multiplier. So I just define one function called multiplier. It takes the number as an input. Okay, this function takes number as an input, then I simply return number multiplied by factor. So I mean this factor that I'm talking about. Okay, number multiplied by factor. Okay, and now what I do is simply returning the multiplier. So what I'm doing here, this is one function called make multiplier. These functions has another function inside it that is called multiplier, and it takes one input, and this input uses the parent function's input also. So this make multiplier is the parent function, multiplier is the child function, right? So in this hierarchy, multiplier is the function which is inside the parent make multiplier function, and this make multiplier function returns the child function that is called multiplier. Please note, I am not calling this function. It is just returning the function. It is just giving me the function. I'm not calling it because I'm not giving the parenthesis like this here, right? So I'm not calling it, I'm just returning it. Okay, so functions can be returned from other functions. So this is one function, I am returning one function from other function. So I'm returning this multiplier function from make multiplier function. Okay, so this was the closer example. So if I just show you by calling it also, so let's say I'm giving one variable name double equal to make multiplier, make multiplier. Okay, yeah, make multiplier. So what I pass, let me pass 2. Okay, and if I just print double, what will happen? What do you think? So this double will return the multiplier function. It does not execute the function. If I print, you will see it is showing that when I printed double, it is showing function make multiplier local multiplier at this. So that means this is returning this multiplier function which is coming for make multiplier function. Okay, and this multiplier is the local version of the make multiplier. But that means for this make multiplier function, this multiplier function is locally available in its local region, like the LGB rule that I discussed in previous videos, right? So the same logic. So double equal to make multiplier 2. So print double. So this is the function that I got. Now since double is containing the multiplier function, now I can call it, right? I can simply call it like double. I'm simply printing it. I'm just calling, by calling it, I'm simply printing it. Okay. If I execute this code, see why I got an error, because if you recall, multiplier function takes one input. I have not provided that. So it is saying type error, missing one record position argument number. I have not given the input, so I give it 2. So answer should be 4, right? Why 4? Because number multiplied by factor. So factor I had already given, that is 2, and the number already given as 2. So it will be 4. Okay. So and another thing, if I show you, print double dot underscore closers closer 0 dot cell contents. If I show you that, see, so the inner function, that was the make multiplier function, it actually remembers what you have provided. This make multiplier function is remembers what you have provided. So you can see when I call double, and inside the double when I call the closer, so this thing is called as closer, that I have already told you, and this closer. Okay, so when I check the cell contents, that means contents of this function, it has recalled the input that I passed. It has recalled the input that I passed. Okay, so that's how it works. If I pass 3 now, if I pass 3 now here, execute the code. See, it has recalled the 3 that I have provided. Okay, it has recalled that. Okay, so I can comment it out for your notes. The inner function remembers its inclusion scope. Okay, and this is a closer. This is a closer. Okay, this is a closer. Okay, so if you see the double, which is this function, it actually recalls the input that I passed here. If you see make multiplier input, I pass the factor here. This double, which is actually the multiplier, it is recalling the input for factor that we provided. Okay, this is another kind of characteristic that is there. Okay, great. So again, I have proven this part also, that is the assigned to variables passed as argument returned from other functions. Now we discuss about stored in data structure. We discuss about that now. Stored in data structure. Okay, so I create a new cell and I'll just write the logic. So 2.4. So functions stored in data structure. Okay, data structure. Okay, data structure. Yeah, so function stored in data structure. I'll show that. So let me write few functions. Okay, define add a comma b. What is simply does? Simply does a plus b. Okay, another function I write, I just simply copy paste and just edit them. Subtract. Okay, a minus b. Then multiplication, a multiplied by b. Then division, so a divided by b. Okay, so that's the function. Okay, and I am just simply writing on logic that if b is not equal to 0, if b is not equal to 0, then do this, else return cannot be divisible by 0. So I have taught this in the previous, I should know about it now. So simple if else that I have implemented here. Okay, so this is my function. Okay, these are my function: add, subtract, multiply, division. Okay, so let's say I'm creating one dictionary here now. Operations. Let's say inside operation what I'm passing. So if you want to do plus, then I'm saying add. So I'm creating a dictionary where this plus is the key and this add is the value. Add is nothing but the function that I'm defining. Okay, so inside operations I'm defining one dictionary where key is the operator symbol and value is the operator function. Okay, so again for subtraction this is the symbol sub, then for multiplication this is the symbol for mul, and then for division this is the symbol for div. Okay, all right, so I have defined my function inside operations dictionary, right? So then what I'm doing, I'm simply doing a equal to 10, b equal to 4. Okay, a equal to 10, b equal to 4. Then what I'm doing, I'm running a loop now. So for a symbol comma func in operation dot items. Okay, operations dot items. So what is the operation dot items? If I just simply show you, see, sorry, I think I have to execute this code first, or else it will not work. Execute the code. Yeah, now if you see, if I execute this code, see, operation dot items is nothing but it is a nested. It is a nested. I would say nested items where it contains the list of tuples. Okay, each tuple contains the operator, symbol, and the function. So I have taught this in dictionary videos already, right? So if you call operations or items, what it will do, it will return a list of tuple, and each tuple contain two elements. One is the symbol, another one is the function. So now to contain two of them, you need two variables, right? That's what I did. First of all, symbol will contain the first one, func will contain the second one. So for each loop, it will do it for this, then 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 for this. So it will keep on doing it like that. Okay, so I'm simply running a loop for this now. Okay, then simply printing, maybe I print using f string. Yeah, so a, that was my input, then symbol, that was my again symbol is there inside the symbol, one thing, right? Then I'm saying equal to, then function a comma b. So what is happening here? So I'm printing a simple f string where a will be coming up from here, the symbol will come up from this loop. So first symbol will pick this plus sign, then this minus sign in a loop one by one, right? Then this b is coming from here. Then I'm calling the function. What is this function coming up from here? How it is coming up from? It is coming from this part. This is the add function, this is the subtract function, this is the multiplier function, this is the division function. So this is the actual function which is stored in a variable called func. I am calling the func. So if I call the func, it's actually calling this add function, subtract function, multiplier function, division function, right? So when I doing that, so when I'm doing this, what is happening? Func a comma b. Now I'm passing the input 10 and 4. Simple. I'm executing this code. See, are we getting the answer? Are we getting the proper answer, right? So this is the another example where function stored in data structure. You can see I have stored this function in a data structure called dictionary. Then I ran a loop and I did my entire operation. So by showing you all this example, I hope I am able to prove that to you that Python functions are objects assigned to variables, passed as arguments, returned from other functions, stored in data structure. So I have proven you all this, right? Python functions are objects, and you should keep this thing in your mind for the future references. Okay. All right. All right. So what I do, I will now what I do, I'll simply continue with my further part. Okay. So let me just create a new cell and let me just discuss about it. That is your first decorator. So far we were discussing something that you already know, but I wanted to give you more idea about it. So now what I do, I'll simply discuss about this part. Okay. that is a function as first class object. Okay, so your first decorator. Okay, so I'll discuss about your first decorator. So now I just simply write some notes below. So now that function as objects makes sense, right? Let's build decorators step by step. Okay, I'm preparing this notebook in such a way that you can use it. Okay, so step by step. Okay, so first that example I will show you, that is 3.1 example, manual wrapping. So as I've already mentioned, right, decorator is nothing but it's kind of a wrapping on one function, right? So I'll just show you manual wrapping. What a decorator does internally. Okay, I discuss about that. Manual wrapping, what decorator does internally. I discuss about that thing. What decorator does internally. Okay, so I'm defining one function called my decorator. Yeah, my decorator. Okay, so this again, as I've already mentioned, that decorator that we defined is nothing but it's another function only. Decorator is nothing but this another function only that helps us to wrap on other functions. So since decorator is a function that I have already told you, so I'm defining it simply like def my decorator. Okay, and since we apply decorator as a wrapper on top of other functions, this decorator function will take one function as an input, right? Because what is job? His job is to wrap some other function. Now for that you need to have one function as an input, then only it can wrap now. So it's simply just called func, which is the function that I have here. Okay, okay, so inside this decorator function I'm writing another function called the wrapper. Okay, this is the actual wrapper. That means this function will actually do the wrapping. I mean, wrapping is what? Wrapping means any logic that you want to apply on top of your function. Okay, so that is I'm kind of telling you as a wrapper, right? So I'll show you some examples so that you get it. So you can see define my decorator, and inside the decorator I have another wrapper function. Okay, what it does is simply printing, let's say that maybe normal printing, like normal text before something before the function runs. Okay, then I'm calling the function here, calling the function which I just took as an input. Then I'm simply printing the same thing here below, maybe yeah, and I just say after okay, something after the function runs. Okay, done. And what I do is simply return the wrapper. I simply return the wrapper. Okay, this is what the function is doing. Simple function. Decorator is the name of the function, which is my actual decorator that I am kind of creating. It takes one function as an input, which it should take. Then inside this function I'm defining a wrapper. Now this logic is just for your demo purpose. You can have any kind of wrapping. You can have any kind of logic for this wrapping. What is my wrapping logic here? So whatever the function I will send inside this decorator as an input, whenever I call this function, whatever this function will do, it doesn't matter. While calling this function, it should print this text. Then it should call this function, let it happen whatever it wants to do. Then it will print simple this text. That's it I'm doing. Okay. So if I do that, if I define one function, let's just say hello. Defining one function, say hello. It's a normal function. It doesn't take anything. Like, let me keep a simple function. It doesn't take anything. Simply return hello world. Okay, hello world. Okay, no issues. Function is okay. So now what I'm doing? I'm calling my decorator. My decorator. I need to pass one function inside this function. I want to pass this say hello function. Now see what will happen. See, when I call this, I got what? I got one function because I got wrapper as an input. I mean not input, sorry, as output. I got wrapper as output, so I stored this output here. And since this output now contains the wrapper function, and now I can call it. I'll just call in this function called output. Okay. See what it is happening. Okay. Actually, I had to print, not sorry, my bad. Print, not return. That's why we are not seeing any output. It should be print. Yeah. Now see. See, can you see? It's printing before something, before the function runs. Then hello world. Why? then after something. Why hello world got in this middle section? Because when I call the my decorator and I pass the say hello, if you see the flow in my code, it takes the function, then I am simply calling this wrapper function. What this function is doing is first printing this, then it is calling the function. Now when it call this function, is actually called the say hello function. What this hello function does is simply printed the hello world. That's what it's doing. So it's simply printing whatever this function logic is saying, then it's simply printing the next line. Now this is the exact work of a decorator. So what is happening here? You have your own decorator logic and you want to apply some wrapper on top of it. You don't want to take headache of the decorator. Let decorator writers will take the headache. You want your function to be used, whatever function you want to write, you write. You just want to apply this decorator to decorate your data. Okay, so you can decorate it like this. So let's select this too, like this and like this. Then this kind of decoration. I want to do this kind of decoration. So same decoration I'll do for the below also. Let's say. Okay, if I call this function, if I call this function, if I call this now, if I call this. See, isn't it beautified, right? So this is how it happens. Okay, so now the thing that we did, we call this decorator like this, right? Now instead of calling it like this, I have already discussed one method called @, right? We will use that. So in real world, people use @ instead of calling it like this. Okay, so how to call the @? Simple. This is the function. Let's say I'm defining a new function. Let's say hi. Say hi, a new function. Say hi, and it's simply hello hi, hello hi. Okay. So now what I want to apply decorator on top of it like this. Now without calling it like this, what I do, I simply call it like this. My decorator. That's it. Done. If I now call this say hi function, see, same thing. Now same logic you could have written it like this. If I just show you, same logic you could have written it like this. Say hi. And you had to do like output. You had to call it like this. See, same thing. Why we got it like this? Because we called it 2 times. That's why maybe I simply call output. You got the function. You simply call output here. See, it's showing it like this. Okay. Why it is happening? Because if I do output 1, now it will work. Why it is printing 2 times? Hold on a sec. I'm not sure what is the wrong with this function. Okay, my bad. Yeah, why it is printing it 2 times, you know? Because this say hi is already attached with this decorator. Since it is already attached with the decorator, it is printing this part 2 times. So what I needed to do, I needed to show you with some other example, but I hope you got it. I hope you got it mostly. So you can, if you want to call decorator, you can call the decorator like this using @. Same way I called it here. We do not call it like this, we call it like this. This is one of the example. Okay, I hope I was able to explain that to you. Yeah. Okay, let's do some more thing also. I'll just show you some more examples so that you get the use case of it. So decorator, as you can see here, right? So we use decorator mostly when we build projects, as well as when we work on Flask, Fast API kind of web frameworks are there inside Python. If you work on these, in these cases, you can easily work on the decorator. So there you need to work on decorators. Okay, great. So what I do, I simply do the 3.3 example, that is decorator that works with function arguments. I'll show you some more examples so that you get it. Okay, function arguments. Okay, so what is happening? I'll define a decorator function. My decorator, again, new decorator, my decorator. It takes one function as an input, as I said. Okay. Now inside this function, I'm defining another wrapper. Again, it is not mandatory that you need to use wrapper. You can use any kind of function that you want to implement, any kind of wrapping you want to implement. But just this is for example. So wrapper function I'm defining here. Okay. Then I'm passing start args and star kw args. So I have discussed about these two things in very detail in previous videos. If you haven't watched that, please watch it from the playlist. So yeah, so wrapper is the function where I have star args and star kwargs, right? So now define wrapper and I'm calling the wrapper. So what this function means, it means that this wrapper function can take any kind of input. It can take any keyword argument, it can take any positional argument, it can take unlimited input. No restriction in the input section, right? So what it will do, I just simply comment it, accept, so that you get it, and accept any arguments. Okay, accept any arguments. All right. So what I do, I simply call result, which is a variable. I just call the func. And I'll pass this input only. So this is the function that I provided as an input, and in this function only I am passing the star args and star kwargs, right? So that means this function also takes any kind of input. Okay. So yeah. Then what I am doing, I'm simply what I do, I simply first print something. Okay. I simply print that sorry, f string, no? So calling then this func dot underscore name underscore with args equal to args and kwargs equal to kwargs. Okay. So function dot name then with args and kwargs. So it will print whatever args or keyword argument that we pass. It simply print that. So if you call func dot underscore name, it will return the function name when I pass the function as an input. Okay. Result equal to func. I'm calling the function. I'm passing these inputs. Okay. Then I'm printing f string only again. So yeah, I simply print function dot underscore name underscore. This will simply return the function name returned this result. So I simply just printed it has returned this result. That's the wrapper job that we have. Okay, and simply what I do, simply return the result. This wrapper function return the result, and now I return the wrapper function. Now in this case, I am simply printing it like this, and at the end it is returning the output. The output is result when I call the wrapper function. Okay, so this is the scenario right now. Okay, great. And now what I do, I will not call it like the way I have showed you. I will show you call it using @_ method. Okay, you should practice the @_ method. So I'm defining one function called add, which takes a comma b input and simply returning a plus b. Okay, and I want to apply the decorator that I just defined on top of it, my decorator. Okay, yeah. Done. So now if I call this add, and then if I pass 12, see I am getting, see what I am getting, calling add with args 12, kwargs empty, add returned 424. So what happened here? So see, if I just do a bit zoom out, yeah, see I have called the decorator here, right? So this add function went as an input for this func. Now this func is nothing but add here, right? So when it came here in this logic, it simply called calling, see, showing calling add. So from this func dot name, it got the function name. Okay, then with args, so I got 12, but for kwargs I got empty. Why? Because see how I call this, I have called this based on positional argument. If you recall the positional argument that I discussed, now I am calling this as based on position. If I do 13, 25, why? Because now 13 becoming a, because it is based on the position, and 12 becoming b. That's why we did not get anything into kwargs. Then it is printed func name, which is add, see, returned result, so return 25. So result contain the 25. It is called this function here. That means it is called the add function here. It give me 25 and it has returned the result as 25. Okay. Now if I could have given it like this, a equal to 13 and b equal to 12, let's say. See now arg is becoming empty. Why? Because now it is not positional argument. It is keyword argument. Because a and b I am passing now it does not matter about the position. I can do it like this also, right? Position does not matter now. If I do a equal to 10, it will not be an issue. See, showing up b equal to 12 and a equal to 10, since it is a keyword argument. That is why this kwargs is capturing that. Okay, that's why I have given it like this. Why? Because we don't know, right, what kind of function user will write. We don't know what kind of inputs they will write, right? So that is why we use this star and double star arguments inside the decorator, so that it can support anything, right? So this is one of the example. If I just show you with some other example also, let's say another function, let's say called greet. Greet is the name of the function. Okay, it takes the name as an input and another input called greeting, and for the greeting by default I am passing a value called hello. So greet is the function name, greeting equal to hello. So hello is the by default value for this. Okay, so for greet what I am doing, simply returning using f string that greeting. Okay, greeting then name. Okay, greeting name. Okay, done. So now what I do, I simply add the decorator here with that. My decorator. Okay, greet. I have called the greet here. So greet, I have called the greet. So in the name I am passing the, let's say, Tanmay, and that's it. Greeting I am not passing. Why? Because by default it takes hello if I don't pass anything. So call this one. See, it's coming hello Tanmay. How come it came hello? Because greeting default value was provided, and then my name I have provided. And if you see in the calling section, kwargs name Tanmay, because it was a keyword argument. That's why. If I just remove this name and call it now, then you will see it will come up here, because now it became position argument, right? So I hope this part is also clear for you guys. Okay, so now we discuss about some more example, that is the 3.4 example. Some practical example I discuss now. Okay, yeah, so a simple logger decorator. So we are going to write a simple logger decorator. Yeah, we are going to simply write one simple logger decorator. We are going to write about a decorator, simple logger decorator. Okay, what does it mean? A logger simply log things, log data. That's it. Okay, so what I do is simply define one function log. Again, this is my decorator function. Okay, it is not mandatory by the, so it does not mandatory that your decorator name should have a decorator text into it. It can have any kind of name, no problem in that part. Okay, your decorator can have any kind of name, since it is a function at the end of the day, right? So you can give any kind of name. So far I was showing you just by using a name called my decorator, but you can have any kind of name. Okay, like we have log as a function here, which is actually decorator that we use later on, right? So define log, all right, and it takes something like func as an input. Okay, so func it will take as an input. And now what it does, so I simply write a doc string here, like it logs every call to the decorator function. Simple. It simply logs every call to the decorated function. Okay, now defining on wrapper. Again, it takes star args and star kwargs. Why? Because I don't know what kind of input output user will have. I don't know that. That's why I don't risk it. I'll take this kind of input. Okay, so first of all what I am doing, so if user is passing positional arguments, like I have shown this example, it was a position argument, right? So if user is passing positional argument, then this args will contain that, right? This args will contain that. So since you know this args contain things in a tuple, right? I have taught that in the previous videos. This args takes things as tuple. Like if you see in this case also, when I passed, if I show here for this add example only, if I show you, it has a decorator, right? So if I pass 12 and 10, that was a simple position argument. See, this args taken this as tuple, right? So that means what I can do, I can run a loop on top of a tuple, right? I can run a loop. So what I do is simply call a thing called for a in args. So since it is a tuple, I can run a loop, and I'm running a simple nested, not nested, sorry, I'm simply running one list comprehension. Okay, I'm running a list comprehension. What I'm saying, for a in args, so it will pick each and every element in a variable, and I'm simply calling repr. RDPR. So what is RDPR does? It will simply show you, see what it does. Return the canonical string representation of the object. So whatever is the canonical string representation of the object, it will store that. Object means what? The input that I pass, that will be stored inside args, right? That input we store inside a one by one. Like in this example, first it will take 12, then it will take 10, right? Then it will simply do the RDPR. That means it will simply tell you, if I just hover over it, return the canonical string representation. It returns the canonical string representation. So I'll show you will see it. So I'll store this output in a variable called this thing args RDPR. Now same thing can happen for keyword argument also. I don't know what user will pass. User may pass args or user may pass keyword arguments. We don't know that. So what I do is simply write the same logic for kwargs also. But since we know kwargs comes up like a dictionary, so I need to run a loop based on items. So for key comma value in kwargs dot items, okay, dot items, then I'll just simply do, I simply do like if this, then k equal to v. Okay, just simply show it like this. Okay, sorry, not k, my bad, it should be key and value. Key and value. Yeah. Key and value. Right? After that, what I simply do, I simply create a new variable called signature. Okay, signature. Maybe let's not create a signature. Instead of that, what I do, I simply print. Okay, like I call f string print. I simply called log. Okay, calling function func dot underscore name. You know, right, how it works now. Func dot underscore name underscore. Okay, that's what I calling. Then what I do, I simply store the result wherever I call this function, right? Func. I'll call this function here. Okay, and then I pass this one because I don't know what kind of input it will have, right? Then what I simply print log func dot underscore name underscore returned result. Okay, simply return the result. And what I simply do, I simply return the result. Okay, I simply return the result, and so this wrapper will return the result, and this log will return the wrapper function. So I need to return it here, return wrapper. So I know I just wrote a very big function. Sorry, I just simply just do it. Yeah. What is the issue? Oh, I forgot to. Sorry, my bad. I forgot to keep it in a string like this. Yeah. Now it is fine. Yeah. So this is the entire function. So I think first time ever I have showed you such a big decorator so far. But in general, in real life, people write decorator like this only. And I hope you have understood the logic that I have written. I have explained each and every line. If you haven't, watch this video again or this part again, or just try to rewrite by yourself. One by one, you can easily get it. Okay. Guys, these things are based on practice. If you practice, you can easily understand. Okay. So it's not rocket science. All right. What I do now, I simply create one function called power. It takes the base and the exponent as an input, where exponent value I am providing 2 by default. Then simply return base to the power exponent. Okay, simple function. If I call the power now here, if I pass base as 10 and exponent nothing, it will be 100 because 10 to the power 200. Now if I add the log decorator with that, what will happen? So if I just simply add a log decorator, see, done, just call it. See, I'm getting all the logs now. If you see, okay, I'm getting all the logs now, and yeah, I'm getting all the logs. You can see log power, calling power, log power return 100. Okay, and this, the RDPs that you defined, right, we can show them also here. args maybe yeah, we can call it like this, args RDPR, and this KW is REPR. Okay. See, calling power 10 and this empty. Why? Because in this case I have provided one queue position argument. If I do a equal to 10, so not a, sorry, it should be base equal to 10, my bad. Yeah, base equal to C. Now for this thing, for this REPR I got base 10. Okay, for this REPR I got base 10, right? So you can see calling power this return 100. So this is a kind of a logger that you have written. Now you can apply this log on top of any one of your function, and it's a generic log, so it will work for everything possible in this earth, right? So great. So I'll show you another example. So I'll try to show you multiple examples on Decorator so that you actually get it. And actually in Decorator there are a lot to know, guys. So there are a lot of things inside Decorator. So this video may cross more than an hour, what I can see by the recording timing, but trust me, this video, this knowledge will last you long till the end of your journey for sure, because knowing this much Decorator is very important for your further concepts that we learn. Okay, and I'm pretty sure no one is discussing about Decorator in this depth for sure. So yeah, a lot many things are there on Decorator that I discuss one by one. So let's go ahead one by one. So another example that I show. Okay, so timer decorator. I define one decorator called timer decorator. Okay, timer decorator. So it measure execution time. Simple. So this functional decorator will simply measure execution time. Nothing much. It's a timer decorator. Is simply measure execution time. That's it. So I'm defining the function. I'm defining import time. Again, I need to import time to execute. I mean to calculate time, right? And define the decorator timer. Okay. Again, this is also a decorator called timer. It takes function as an input. Then what I'm doing is simply defining a wrapper inside it. A wrapper. It takes args and star kw args, right? Then what I'm doing? I'm getting on look start. Start equal to time dot prf counter. What it will do, simply calculate the timing. I mean, when the code will execute this line, what was the time for that? So start will contain that. Okay. Then I am simply showing the result equal to, I call the function. I pass this input because I don't know what kind of input it will take. Okay. Then end equal to this function. Same thing. So it will calculate on what time it got ended. So when the code was executed this line, what was the time? After executing this line, because this function will have some code, right? And those code will take time to get executed. After that, once this line execution is done, then when cursor came in this line, what was the time? So this is my starting time, this is my ending time. So now what I do is simply calculate the elapsed time. That means end minus start. So this elapsed will contain on what time it elapsed. That means what was the timing gap between them. And I simply print function func dot underscore name underscore okay, executed in elapsed, okay, seconds, okay, executing elapsed. So what is this function was the purpose was to calculate the timing. I'm calculating the timing and I'm showing that timing here. Then I simply return the result. Okay, that means this output which I got after calling the function, and this wrapper return the result and I simply return the wrapper function. Done. Your function defined. Now, so now just to simulate the timings now, because I need to show you, or I need to write some code so that it takes a bit time to get executed, so we can see the timing difference, right? So what did I simply write a function called slow number. It takes n as an input, and what it does, total equal to 0. Okay, I'm running a loop for I in range n. Again, you guys now know about this now. For I in range n, what I'm simply doing, I'm simply doing total plus equal to I. So simply I'm running a loop based on the number, and I'm adding the total. Total was by default 0. Then I'm keep on adding the numbers one by one. So total plus equal to I. So you keep on adding the values based on the range given, right? So at the end I return the total. So total is the final output. Okay. So now what I'm doing is simply calling timer. I'm simply calling at the date timer. Okay. Now what is at the date timer? It's nothing but it is a decorator that I'm attaching with this. So if I just execute this and if I call slow now and I pass 10, let's say, see what is the execution time? Execution time was this. And if I increase the number, let's say 1 lakh, 1000, takes some time. If I just make like this, so yeah, now it's taking a bit time because it's a pretty big number, and I think it may break my column memory also. But you will see some significant time now, because though 10, 20, it was taking very small number, right? But when it's about this big number, right, it will take some time. So yeah, so I believe let it take some time. I'll kind of wait for this answer. So you can see the visible number, I mean a visible good number that you can see. Okay, so let me wait for that. We just wait for that, and for now I'll just pause the video. Okay, so I waited a lot of time, guys, but it was executing only. I waited almost half an hour and it was still executing. So what I did, I have changed the number, I made this number, and you can see it took almost 0.1180 seconds. So you're able to see some visible number. I just wanted to show you that. So you can see after adding all the values to this data, we got this big number, and it took almost 0.1180 something seconds. Okay, so this is the decorator. Great. Now we discuss about something different. What is that thing? So there are some issues are also there when it's about writing decorators. Okay, so there are some good practice or bad practices are there that we need to know also. So what about these? So if I define one decorator here, let's say bad decorator. Okay, bad decorator. Okay, it takes function as an input. Sorry, it takes function as an input. Okay, yeah, it takes function as an input, and then what I do, I simply define a wrapper. Wrapper, it takes star args and star kwargs. Okay, different wrapper, star args, star kwargs. Then I simply returning the function func, because this function I need to call, right? This function I need to call, correct? Just call this function. I'll pass this star args and star kwargs. Should be happy. Yeah. Okay, then I simply return the wrapper. Okay, good. And if I just define one function, let's say my function, okay, and they are, it's not doing anything, simply like nothing it is doing. Okay, and if I pass this bad decorator with this, let's say, okay, I just execute this code. Okay, code seems okay. And now if I call my function, and then you can recall this underscore name underscore, if you recall, it is saying wrapper. So the name of this function is showing wrapper, because I am using the decorator here. It is showing wrapper. So the name of this function is saying wrapper. Is it correct, guys? No, right? It is not correct. It should say, it should be as my function, not the wrapper. Why wrapper? Wrapper is the decorator here, right? It should not say that the name of this function is wrapper. It should be my function, because my function is the name of my function, right? My function is the name of my function. Let's say test function. If I give it like this, test function, so that you will not get confused. If I call it like this and if I execute, see. So for test function, name of this function. So when I'm doing dot underscore name underscore, so give me the name of the function, that is test func. This is the actual name of the function, but it is in wrapper, because it is referring this one. So this is an issue that we generally face. Okay. Now to fix that issue, we will use, so the fix is, we will use functools dot wraps. So the fix is use functool dot wraps. Okay, what is the func2? So for func tool, you need to import it, like how we imported time, you need to import func tools. Okay, it's by default inside Python. What you need to do, I'm defining one new decorator called good decorator. Good decorator, passing the function. Then you need to call function tools that I just defined dot wraps function. Spelling is wrong. WRAPS, yes, wraps. Then you need to pass the function. Okay. Then you need to pass the function. So define good decorator func tools wraps function. Okay. I define that. Now this is the line which will do the magic. Function tool. I'm wrapping this function tools in this function. Okay. Now if I just simply call the wrapper, wrapper, it takes the star args and star kwargs. Okay, I simply just return the function func, and instead that I simply pass these values that I just showed you. Okay, and I simply return the wrapper. And now if I just call this same function here, I just copy it, paste it here, I just pass the good decorate. I just call this, and if I now try the test func dot underscore name, dot underscore name underscore c. When I tried this, I got this error because by mistake I had to do this, not this. See, I'm getting now test func. I'm getting the test func now. So the issue is fixed using this func tool. So this func tool, if you use func tool or apps, and if you send the function, it will change these characteristics and it will add the actual name of this function. Okay. So as per that logic, if you can recall, we just wrote this timer function, right? So if I just quickly check for this function also, because this function also has the same issue, right? If I show you that. Now this was the function that I defined, right? Slow number. If I call this slow number dot underscore name underscore sorry dot. If I execute, so it's getting wrapper, right? Same issue. So what change you need to do? You just need to add this line before this line. Sorry, not here. Here. Okay, now try. Fixed. Just by adding this line, it will fix that issue. Okay, I hope we are good with this part, right? Great. So now we talk about another excellent characteristic of decorator, that is decorator with args. So sometimes you want to configure a decorator with parameters. Okay, sometimes what happens, you want to configure a decorator with parameters. So for that we need to learn how to do that. Okay, now for that what we need to do. So first of all, to show that thing as an example for you, what I do is simply first define one decorator. Okay, I have defined one decorator. Let's say I name this decorator only. So I'm passing the function name as decorator. Okay, it takes the function as an input. Okay, then again I'll use func tools. Same logic, right? I use this func tools, and I just simply use it here. Okay. Then what I do is I simply define one function called wrapper. Okay, I pass star args star kwargs. Okay, and what I do is simply I just call results. Okay, or maybe, so I have defined the results here, right? Now what I do, I simply I give an empty list. I give an empty list here for this. Okay, so now what I do, I simply run a loop for I in range. Now I want to run this loop maybe 3 times. let's say I want to run this loop 3 times, and then what will happen, this loop will execute my function. It takes this arguments as input. Now why I'm running a loop? So because what I want creating one decorator which actually calls one function. I mean, whatever function I will attach with this decorator, that function will get executed 3 times because of this thing. Okay, will get executed 3 times, and the result will be stored inside this results variable, which is a empty list. So I simply do results dot append result. Okay, these are the append results. Okay, then simply return the results because this is what I got as an output results. Okay, and then I return the wrapper. Okay, done. Code is done. So if I just show you like this, a define say hello, and it simply prints hello. Okay, I just attach this decorator with that. Sorry, yes, we print hello inside the brackets. So yeah, if I call this hello now, what will happen? You'll see I got hello, then I got none. Okay, so I called the function and I returned the wrapper, and I got the output as none. What happened here? First of all, 2 questions I have for you. First of all, I want 2 things that should happen. The first thing is, I do not want to fix this number. Like you can see, this got executed 3 times, right? This got executed 3 times, right? This got executed 3 times, but I don't want it to execute 3 times. I want to parameterize it. I do not want it to execute 3 times. I want to parameterize it. Now, when I call the decorator, because what is the purpose of this decorator? The purpose of the decorator is to execute my Python code or my function 3 times, n times. I do not want 3 times. I want n times. How do we do that? That means what? I want to run my decorator in this way. Now, when it's about passing your own custom arguments inside decorator, you cannot do directly. For this, what you need to do, you need to pull this entire code inside another normal Python function. Now you can say a different function called repeat. It takes n. Okay, and now this entire code I need to send inside the repeat. So in the repeat n, I am passing the n here, and for this function I need to return my decorator also. Now decorator. Why? Because now this decorator is inside the repeat function, and if I do not return the decorator, it will not work. So for the decorator functional level, I return the wrapper, and for the repeat level, I return the decorator. And now if I call repeat, and if I pass, let's say 5 times, if I call this, see, I am getting hello. Okay, I am getting hello. But why I got none here? Because I did not return it. I am simply printing, right? If you see, I am simply printing hello here. I am not returning anything, right, in this function. And that is why whenever it called this function, it did not store anything. I have told you in the very first videos, right? What is the difference between return and print? Print means it will show you. Return means what it will give you the output. But this func is executing, it is simply printing hello. It is not at all returning anything. So actually this result is not storing anything. It is storing none. But if I do now, after printing, if I return hello, and then if I execute this code, so you will see now hello will be coming 4 times. Because now this is returning hello and it is printing hello. But if you see I'm getting for 4 times, if I want, I can make it 5 times. If I execute this code, so I'm getting it 5 times now. So now I have parameterized my decorator by this. You see, this is the actual decorator function. If you see, this part is the actual decorator code, okay? And Decorator takes only function as an input, nothing else. Just for your information. The decorator takes only function as an input. But when it's about some custom parameter you want to pass, what you need to do, you need to wrap the entire decorator function using another normal Python function. Like I have define repeat, and inside the repeat I have defined this entire function. Define repeat, and inside this I have defined this entire decorator inside this. Again, this is a simple function. It's not a decorator, it's a simple function. I just wrapped it up my decorator using this so that I can pass my own parameters. And this is the example of that. Okay. And I hope this part is clear. Okay. All right. So what I do, I'll show you another example. Okay. I'll show another example. I mean, some useful example I'll show you. So this example would be configurable. Configurable logger with log level. Now, so far, if you can recall, we have defined one logger function just I think few minutes ago, right? Now, what I want that the function that I define, that logger function should have some custom parameter that I can choose, like logger level, logger prefix. This kind of input I need to pass in my decorator, because I just created the logger decorator just a few seconds ago. Yeah, but this decorator was not taking any other input from my end. Let's say if I want to change my log level, if I want to change my log prefix, I want to give user to choose their own options. It was not happening in this logic, but we will make sure that it happens now, since we know that decorator with arguments, it takes it, right? So for that, what I need, first of all, I need to define one function called log. Now this is not the actual decorator function. This is the outside function, like this repeat, like this repeat. So this is the log, which is the outside function, which we actually call anyways. So it takes two input label, and by default we are passing it as info. Okay. So for define logs, I have provided label equal to info. This is a by default data. Okay. So now then I am passing the prefix equals to empty for now. Empty means nothing. Simple. Empty string I am providing. Okay. This is my function. So now in this function I have provided my inputs that I need from the user. Now I'll write the actual decorator code. Okay, so now I define the decorator, and since you know decorator takes only one input, that is the function. Now what I do, again I simply do func tools.wrap first. You know you have to do that. Func. Okay, done. So now what I do, so now I simply define my wrapper function. Define a wrapper, then star args, then star aw args. Okay, then what I do, I simply define my own logic. So first of all, I need to calculate the timestamp. Timestamp. How to calculate the timestamp? So date time, I need to import date time. For that, just create a new cell. I just import date time. Date time. So if you call date time, you'll get the timing data. Okay. So if I just call show you, if you do date time dot now, if you do it like this. Sorry, I think I missed it. Yeah, I should be dot execute. So it will give you date time like that. Okay. And if you try to convert it into string format now, it will show you like this. If you convert to string format, it will show you like this. Okay, this is the current date time. Okay, this is the current date time. Okay, great. So what I'm saying, so yeah, timestamp equal to date time dot now. So if I do this, I will get data like this. But let us say that you are not liking this format. You are not liking this format. You can update your format. How? You have to do this dot stft time, strip time. We call it as strip time. Okay, strip time. Then you need to pass how you want that. How you want. I want in this format. Hour. Then maybe minute. Then second. I want in this format. If I just execute, see, I'm only getting the timing. Okay, I'm only getting the timing here. Okay, in first hour came, then minutes came, then seconds came. Okay, if I execute this, see, seconds is changing because time is going right ahead. So that's why. See, this seconds is changing. So I think after a few seconds you can see it will become 23 because time is going ahead, right? This is the current time. So yeah, see, now it became 23. Okay, it's calculating it that way. So I just do that only here. I simply just copy this section and I simply paste it here. Okay, so I got my timestamp and I create my own tag. Tag equal to maybe prefix. I just choose the prefix that user will pass. Sorry, the prefix. Okay, I'll pass this prefix. Then what I do? If prefix. So if prefix user is passing, then you show it like this. Else, show nothing. So if user pass any prefix when we will call it, you show some tag. If it is not true, show blank. Okay. So this is the tag that I have. Okay. So then what I do, I simply so I define my tag. I simply print it now. I print simple like okay, and then the timestamp timestamp. Okay. Then I provide the label. Okay, I provide the label. Then I provide the tag. Okay, I provide the label. I provide the tag, and then I simply show it like this. Func dot underscore underscore name underscore underscore. Okay, so func dot underscore underscore name underscore underscore. I'm providing that. Okay, and I'm saying it's called. So it is simply showing a detailed manner. What was the timestamp? What was the label? What was the tag? That function called. So it will tell you every detail on which time the function called. Okay. So then what I simply try to call this function func. Maybe result equal to func. I pass my thing star args and star kwargs. Same thing. I pass that, and then maybe simply I print the same logic. Maybe just by calling this. I can say returned this. What it has written? It has returned this result. Okay. It has returned the results. Okay. And then I simply return the result. Okay. Done. So now what I do? Simply return the wrapper. So I am returning the wrapper for the decorator. For the decorator function, I am returning the wrapper. Now for the log function, I need to return this decorator. So now what I do? Simply return the decorator. Okay, decorator. If you see now, this is the scenario right now here. Now if I call, I just show you with some example. Let's say I'm calling this function, or I'm writing one function. Let's say add addition function, a comma b, and I simply return a plus b. Okay, a plus b. Now what do I just call my log decorator log. Now log takes what? Log takes level. So let's say level equal to debug. Okay, and let's say prefix equal to, let's say, math prefix. If I execute the code now, I just call this one now. 12 execute this code. See, I'm getting debug math array called. I got this add return 24 and 24. So now if you want, you can pass anything you want. I want info. I want empty. You can do that too. It will work. See, now I have given you the power to write your own function. Okay, I given you the power to write your own function so that you can do your job. Okay, I hope this part is also clear to you. Okay, now so I guess we are almost done with the Docker. Sorry, not the Docker. We are almost done with the decorator. And what I do now, the last part that I'll explain. I mean, it's not the last part to be honest, but as far as syllabus, whatever I have covered so far till the last video, as per that knowledge, this is the last part of our decorator series. So in next videos, it will come the other concepts of Python and machine learning and all. But wherever new logic or new concepts needs to be introduced, I'll make sure that I'll teach you that, and then only I will continue with the further topic. But for now, whatever things we have learned so far, I think it should be good. Okay. So the last part is stacking multiple decorators. What is that thing? So you can apply multiple decorators to a single function. Okay. They are applied bottom up. Okay, I'll show you some good examples. So I'm defining one function called make layer. So since I want to show you multiple decorator example, stacking multiple decorator example, what I do, I will I'll create some decorator which takes custom arguments also, okay, which will have custom parameters. So make layer, which takes name as an input. Now inside this function, I'll define my decorator. Then defining decorator, and it takes the function as an input. Then the func tools dot wraps func. Okay, func tools dot wrap funcs. Okay. Then what I do is simply define a wrapper. Again, same function wrapper. It takes the star args and star kwargs. Okay. Then what I simply do, this is my define wrapper star args star kwargs. Then I simply print entering maybe name f string. Then call this function result equal to func. Then call this function star args and star kwargs. You can call this function and then simply print the same thing. You can say like exiting name. Now simply returning the result. Okay. Returning the result. So and then I return the wrapper. And then simply return the decorator. Okay. Simply return the decorator. Okay. So this is the function that I have defined here. Okay. So this is the function that I have defined here, right? So this is the decorator I have defined here, right? Now what is happening? If I'm defining one function called, let's say, core function. Okay. Core function. Okay. Core function, and it does nothing, to be honest. It simply print core function is running. Okay. Now if I want to apply this decorator, so what I said, stacking multiple decorators. So what I do, I'll define multiple decorators here. 1 decorator, 2 decorators, 3 decorators. Okay. So I just simply call them at the date. Now this one take a outermost. Let's just show you how the execution happens. Okay. Then B middle, and the C, that is innermost. So A outermost, B middle, C innermost. Okay. So this was the logic altogether. A outermost, B middle, C innermost. If I just say I've defined my stack, decorator stack. If I execute the core function now, let's see what will happen. See, it is showing entering A outermost, entering A middle, then entering innermost. If you see, then exiting innermost, then exiting middle, then exiting outermost. So first of all, it follows the same hierarchy. Okay, it follows the same hierarchy. So it does bottom to up. If you see, first of all, it takes, like when I provided the outermost, right, what it did. So as per our code, if you see, entering name, I provided entering name, right? This is the name. So it has executed this decorator first. Okay. Then entering B middle. Then it has executed this also. Then innermost, if you see, it has executed all of them. It is called the function, which was this one core function, which our core function is running. Then what happened? Then this one exited first. Then this one exited second, if you see, and this one exited at last. So this is a kind of a hierarchy when it follows. If you work on the multiple decorator stacking like this on one function. Okay, so this is all I wanted to show you decorator. So for now, whatever we have started in decorator, so that's all I would say I wanted to teach you guys. So I hope you guys have enjoyed my decorator video. So I know the video is a bit bigger one, but I hope you have learned a lot about decorator. I have tried to teach you most of the possibilities about decorator that you may face in your interviews or you may face while building your own projects, right? So I hope you guys have liked this video. So please make sure that you follow these videos, everything, so that you can learn AI properly. So thank you guys for watching this video. We'll catch up next again with some new topics. So bye bye everyone.